Hello and welcome back. Without further ado, please allow me to introduce Engineer Kanani from Rahab Consulting Company, a seasoned civil engineer with extensive experience in both national and international projects. With a wealth of expertise garnered from diverse endeavors, Engineer Kanani has played an integral role in the successful execution of numerous infrastructure ventures. His dedication to excellence and proficiency in navigating the complexities of civil engineering make him an invaluable asset to any project. It is with great honor that we welcome Engineer Kanani, whose wealth of experience promises to enrich our discussions and endeavors. So please join me in welcoming Mr. Kanani.
خدمتتون عرض کنم که این یه لکچر تقریبا 1-2 ساعته بود. من اسکویزش کردم توی 30 دقیقه و الانم فکر کنم با توجه به وقت و روز دوم و بعد از نهار فکر کنم دیگه یه رو بیشتر صحبت نکنم بهتر باشه. In the name of God and engineers, He created the earth, and we engineers created what is on it, above it, and under it. So it's not too much if we call engineers hand of God. It's such a pleasure to be here presenting to a group of elite professionals like you. I do my best to squeeze my 1 hour lecture in less than 20 minutes, even less. What I'm presenting today is a piece of art made by Iranian engineers. I'm not familiar with this thing, so maybe it takes some time to go through the slides. You changed it. So I introduced myself. Let's go to the next one, please. Or I can use this thing. Is it the?
Yeah, it's working.
Yeah, good. I had many notes. I think it takes time if I go through them, so I make it simple. If you want to go from Tehran to the west of the country, there is just one main road, which is Tehran-Karaj-Kazvin highway, which doesn't see the demand. We need a second one, and we are building one. The Hemmat highway, which goes to the west, there is, when it tries to pass Karaj city, there is a bottleneck. And that bottleneck is the Karaj River, which is wide, like 600-meter wide valley, 100-meter deep. So we need a huge bridge for that. Of course, there are many different types of bridges. It's not necessary to go through all of them. We pick 2 of them which are more relevant to our project. Just sorry, I have to look at some of my notes at least. The first one, Girdar Bridge. Where did it go? The first one, Girdar Bridge, and the second one, Cable State Bridge. These 2 are the main bridges we could consider for this project. Oops. So let's look at the first one. First one is usually a massive bridge with heavy construction, and it's suitable for up to 150 span. It's not suitable for what we are doing here. If you go beyond that, the box itself will have a dimension of 10 meter in 10 meter, which will be really heavy and not cost efficient. it will be something like this for this project. The second one, the cable stayed bridge, which usually have two or more towers, and the cables between tower and the main body of the bridge hold the whole thing. This one is also not so suitable because we are hanging our lives on that cables. Even in United States and in European countries, more than 75% of bridges doesn't receive uh, enough maintenance. So this one definitely doesn't suit for a country in Middle East, which we can imagine how the maintenance will be. This is the general shape of this type of bridges, a very tall tower and main span, which is not suitable for our project. They come in very different shapes, but the concept is same. Uh, let's talk about the design criteria. So we didn't want to have the heavy first one, and we didn't want to have the maintenance needed second one. What we do, actually, I had lots of explanation on each of these slides, but I'm just like trying to go through them really fast because already we are late in our schedule. So I just skip them. I'm telling the main concepts. Um, with combining these two type of bridges, we chose extra dose bridge type to pass Karaj River Valley, a hybrid bridge structure blending characteristic of girder bridge and cable stayed bridge, spanning between, it can bear weights between 200 meters to 500 meters. So it's definitely suitable for our project. So what we have here, what makes this type of bridge safe? The main body of the bridge, the dead load will be carried with the box bridge, and the traffic load will be carried with the cable estate. So if we compare these three type, let's, I guess, so I have to go in myself. This one was the girder bridge, which would be really heavy, and that one was the cable stayed bridge, which was not safe. I mean, in case of because of maintenance issues, it was not safe to build to be chosen for this project. So we combined these two. Of course, we didn't invent this type of bridge. In the middle is a combination of these two type of bridges, which has a lower tower and a stronger body. I mean, lower tower comparing with that one, and it's not as heavy as this one. Here I'm comparing the cross section, which obviously our choice is this one in the middle. If I wanted to go through the details, it would take lots of time, so I'm just going really fast. What it provides to us? It provides optimum cost and safety. Sorry, let me find my place here. To compare this, in this specific project, which the main span is 170 meter, it gave us 20 percentage cost efficiency comparing to girder bridge, and 60 percentage cost efficiency to cable stayed bridges. Of course, it's much safer. This is the ultimate design we come up with, and actually it's under construction. They are already building that. Let's look at the design. These are the 5 different parts which we had to think about when we were designing this bridge. Foundation, pier shaft, pylons, deck, cables. We don't go through all of them. This is the foundation of one of the piers. Dimension is 38 meters in 20 meters, and it has 2 meters, it's 2 meters deep in the ground, which concludes in 1,700 cubic meter of concrete work. It is something like this if you zoom in. Pier shafts, there are 2 main pier shafts. Each of them is a double or, if you wish, twin piers, which the tall one is 90 meter, roughly 90 meter, and the shorter one is about 70 meter. And there are some minor piers which give access to the main span. Well, we pass them. This is the main part. This is the difficult part of, in design and also in construction. The deck of the box girder bridge is under construction now using the segmental construction method with the help of a balanced couple chariot system. There are 2 chariot systems which move at the same time. One of them to this direction and the other one to the other direction to keep the balance under construction. Well, we escaped the cables. Oh, numbers. Let's look at the numbers. 530 meters is the entire length of the bridge. 33.6 is the entire width of the bridge. 173 meter is the main extra dose span. And this bridge, when it's finished, it can support 6 main traffic lanes plus 2 reserve lanes. Oops. These are some more numbers. 5,500 cubic meter of concrete, about 9,200 tons of steel, and about 1,000 tons of cable is needed to complete this bridge. This is a video which I'm not sure how I can play it here. And ویدیو رو باید پلیش کنیم. خب نه نمیدونم چجوری این ویدیو رو صداش داره پخش میشه یعنی داره پخشش میشه. Well, due to technical problems, apparently it's not working the video. So let's just escape it. Okay, let's forget about it. Um, these two gentlemen, my colleagues in Rahab Consulting Engineers, uh, Dr. Ala Rasul and engineer Sofdil, are the creator of this bridge, and they shared the knowledge in this book. If you are interested, or if you have any question, you can find that in this book, or you can contact us. We are more than happy to be there for you. When we were talking about this presentation, the first thing came to my mind is the fact that I wanted to highlight this thing is made in Iran entirely. In case of knowledge, in case of construction, and in case of everything. And we should take in account that Iran is under heaviest sanctions, and we could not even contact our colleagues in FIDIC, ask them for help. So it's done by Iranians in Iran. So proudly we call it made in Iran. Usually with this, usually for this type of mega projects, there is a combination of many local and international, multinational companies coming together, working for many years to design the thing and then start building that. But here we were really, really alone. We Iranians. Uh, I really tried to go fast through everything. If I wanted to go to the details, it would take lots of time, and already we were behind schedule. So I even don't know. I didn't start my timer. Every time I start my timer to make sure I don't pass the time. So it was not necessary. I think in 10, 15 minutes, it's finished. So we called this thing piece of art made by Iranians in Iran. Thank you for attention. I wish I could show you the video, the clip which we had, uh, but maybe for another time. Thank you. Okay.
Thank you very much, Dr. Kanani, about for nice presentation. I have a bit time. Do you have any question about this presentation? Okay, I have a question about the wind loading. Has a flutter analysis been performed on this bridge or not?
Of course, definitely. Definitely. There are lots of studies and examination, and they use different softwares to make model of this bridge and examine it. But if we wanted to go through all of that, it would take some like 2 hours to cover everything. But Mr. Sofdale is the person to contact if any question in case of the design of the bridge or construction or whatever. We are available in Rahab Consulting Engineers, and Mr. Sofdale is the person to contact.
Thank you very much.
Thank you.
Have a nice day.